What do you know about an equilateral triangle? All sides are, oh, good. An equilateral triangle, all sides are equal. Hey, if all sides are equal, that means that all whats also have to be equal? All angles. So that means an equilateral triangle is also called an equiangular triangle, aka equiangular, right? And it looks like this. These are the triangles that we've been drawing since like kindergarten, first grade. They're the ones we always draw. They're perfect. And we can show that they're all congruent sides. And what else? Can I go back there and get it? Another pencil? Yeah, go ahead. What else can I do with this? Mark up the angles. Now, if all of the angles are congruent, then what will their measures be? What will each of their little measures be? 60 degrees each. That is an equilateral triangle. Doesn't matter if it's equilateral, all the angles are still 60 degrees each. If the angles are 60 degrees each, that means it's an equilateral triangle. Got it? So if I were to give you, all right, let's just take a moment here. Does everybody have this? Okay, tell me when. Go ahead. Isosceles triangle. What do you know about an isosceles triangle? Only two sides are equal. Well, you should. When you classify triangles, you should have known that. Two sides are congruent. Now, that's important to us, big time, folks. Here's the thing, okay? There is a theorem. Well, is that in this one? Yeah. That says, and I don't know what it's officially called, but it says, you got to write this down. If two sides in a triangle are congruent to each other, I'm going to move out of your way in just a second. Then the two angles opposite those sides are also congruent. And I think that's called the isosceles triangle theorem. Yeah, that's on page 273, and it is the isosceles triangle theorem. Okay? If two sides in a triangle are congruent, then the angles opposite those sides are also congruent. Now, what in the world does that mean? Could I take this picture of this triangle if I were to extend those two congruent marks, where would they go? Let me name these points. If I name this triangle A, B, C, okay? Come up here and mark where they would go. Joseph. Yeah, you. Okay. If you were to extend those congruent marks, where would they extend to? If you were to stretch them out, where would they go? Okay, where would they go? Where would they end up, though? Come up here and draw it. Who cares if you make a mistake? I got your back. Ain't nobody gonna mess with you in here. Oh, hey. No, that's exactly what I needed to see. Hey, I want you to draw and extend those. Here's what I would do, though. If you will, let me back this up. I should have told you this. Make them dotted. And Joseph, that's my fault. And draw an arrow at the end, okay? Check this out. Folks, when you draw that arrow across, it shows you which angles will be congruent to each other. So what that's saying is, what this theorem, this isosceles triangle theorem is saying, is if segment AB, oh, Lord have mercy, if segment AC is congruent to segment AB, then angle C is congruent to angle B. That's what that theorem is saying. The theorem, it never makes any sense to me until I apply it to a picture. I have to attach it to a picture and then look at it. And I go, oh, okay. All right? So if those two sides are congruent, then those two angles, those two opposite angles are congruent. Does that make sense? Okay? So check this out. If I were to draw another triangle, we're going to call this ABC as well. Okay, we'll call this example 1. I want you to name the congruent angles. That's what you're given. Side AB is congruent to side AC. Tell me which angles are congruent. A and C? Okay, oh, B and C. All right, here's a helpful hint. If I were to have this picture on my paper, if you'll turn your paper so that your triangle looks like this, you'll get it right every single time. If I were to turn my paper, okay, I can't do that with the smartboard, but y'all can do it with your paper. If I were to take this, some of you are going to have a trouble unless you do this right here. And you'll find out which angles are congruent. Like Maddie said, angle B is congruent to angle C, and she's right. Did you draw the arrows? Okay. If you don't want to draw the arrows, folks, just turn your paper and make sure that your congruent sides are like this right here. And then automatically your base angles will be congruent. You see what I'm doing here? Not really? Did you get B and C were congruent? Nope. All right, here's another one. Let's look at another example then. Don't say anything out loud. Look at that picture. You got triangle CDE as an isosceles triangle. You know that side CD is congruent to side DE. Okay, Lauren? All right, now. You got to do one of two things. If I have an isosceles paper, me personally, y'all know how I am with parallel lines. When we work parallel line problems, how do I always like my parallel lines to be? I want them to be this way, don't I? I want them to be sideways with my transversal going through them, and if it's not, I'm going to turn my paper so it is, right? If my paper, if I had this on my paper, I would have to turn my paper that way and set it up so I'm looking at this right here. That's what I would have to do, okay? And you can turn your paper. Now, when I do that, where are my congruent angles going to be every single time? They're going to be on the bottom. And it cuts out the guesswork, won't it? How many of you had on your paper that angle C and angle E were the congruent angles? Okay, that's what you should have had. Yes?
it also just be the size of the lines that don't have any thick lines?
Yeah, it'd be those two angles. Because these, you can't really extend these, can you? They don't really extend nicely to the opposite corners. Guys, do you see this, yes or no? I'm going to tell you right now, I'm not going to spend a lot of time on this because this is a very easy concept. And if you just sit there like a knot on log and you just copy down what's up there, because you're just copying words, you're not paying attention to what you're writing down, then a very simple concept is going to become very not simple for you. And this should be a piece of cake. Do you have questions? I can back this thing around and I can say, okay, I've got triangle XYZ, and triangle XYZ has two congruent angles. Name the congruent sides. This is completely opposite of what we just did. You got it? What's it going to be? It's going to be here, there and there. Yeah? So it's going to be segment XZ is congruent to segment what? ZYYZ. It doesn't matter how you write it, just as long as you write it. How many of you got that? You understand that? Here's another one. Oh, here's what. Here, hold on. You got triangle KLM. Name the congruent sides. Hey, what's different about this one? No tick marks. It actually gives you the actual measures, right? So what are the congruent sides? LK. And does anybody bow hunt in here? Has anybody ever shot a bow and arrow? Okay. When you're standing here and you're pulling back that bow, right? If you can imagine yourself here in this corner, and you pull back that bow and you're shooting that bow, where's the bow going to hit? Boom! It's going to hit right there, won't it? Okay? So KL is going to be congruent to, boom, what's it going to hit? LM. That's just another way to think about it. Okay? Does that make sense? Yes or no? Okay. So mathematically, what are we going to do with this? Folks, this is called, by the way, the converse of the Isosceles triangle theorem. Write that down. When we start with the angles and go back to the sides, that's the converse. Remember, converse just switches the hypothesis and the conclusion? That's what we're dealing with here. That's what allows us to figure it out. All right, so let's do some numbers. Let's work with numbers in algebra because, oh, I don't know. Here we go. Find x. We've kind of already done this. For the missing angles. You got this triangle. You got that top angle is 22 degrees. How many angles do I have to find? I only have to find two. How am I going to find those two bottom angles? What's that mean, Maddie? The other angles are congruent. So this is congruent to this. Folks, easy. Easy, easy, easy. How are we going to find those angle measures? What? All right, stop. 180 minus 22. 180 minus what we're given, and that gives us 158. What are we going to do with 158, y'all? Why are we dividing by 2? Because there's 2 congruent angles, right? 158 divided by 2 is that 79? 79, those are your missing angles, folks. 79 degrees. Isn't that kind of neat? Could you go back and check? How? Add them together. They better equal what? 180. There we go. Here's another one. All right. That's 3x degrees and x plus 44 degrees. What the world? First of all, what would Miss Perry have to do to her paper? I got to turn it, I got to set it where it's looking like this. So I'd have 3x and x plus 44. That's what I need to see personally, okay? Say what? Why? Because those 2 sides are congruent. If the 2 opposite sides are congruent, what do you know about the 2 angles? They're congruent, right? So if these are congruent, then can I say that 3x is equal to x plus 44? Oh my God, what do I do then? Let's find x. And then hey, are we doing geometry or are we doing algebra? Now we're doing algebra. 44 divided by 2 is 22. What if I needed to know the angle measure? That's x. Plug it in. 3 times 22 is what? Who? 66. Would I have to go 22 plus 44? No, it better be the same thing, right? What do you think? It is easy, right? Okay, y'all remember that. No, not really. It really doesn't. How about this? What about the other? Good day in the morning. Here we go. What about the other triangle? Okay? I don't know, not for the algebra stuff. Oh. Check it out. These are easy. Psst. Say what, Maddie?
Does that mean the other angles are
You all right? Okay. All right. That was scary. All right. There are several different ways to do this problem, okay? I could say if these 3 sides are congruent, what do you know about all 3 angles? They're congruent as well. So I could, hey, option number 1. I could say that 2x plus 32 plus 2x plus 32 plus 2x plus 32 is equal to how much? 180. Now, that would be a big old pain in our behind, but is it doable? Yeah. Absolutely, it's doable. We'd combine like terms. We would solve the equation for x, right on? There's another way we could do the problem.
multiply it all by 3.
Oh, Smarty McFarty says 3 times 2x plus 32 is equal to 180. Very good. Little less algebra. It does look easier. Totally doable, right? Come on, somebody. There's another way to do this problem. First of all, what kind of triangle is that? Hold up. What kind of triangle is this? Oh. It's an equilateral angular triangle, right? There's one more way. Amber, what were you saying? Yep, this isn't about sides. This is about angles. All right, if we were to set, let's think about it. Do you need me right now? Yeah. All right. I just want you to think about this. Because, Maddie, what you're saying is all of these angles are congruent, right? Okay, and you're right, they are. But if I say 2x plus 32 is equal to 2x plus 32, let's think about that algebraically. Subtract 2x, subtract 2x. What just happened? What? Look at this now. What just happened? What? Can I have an angle measure equal to 0? So does that kind of cause us to chase our tail? Kind of puts us in circles, doesn't it? All right, so this is not what we want to do. Come on, y'all. It's an equilateral triangle. Come on, Justin.
The stuff for x, I just done like this 2x plus 32 equals 180.
Oh, you're warm. You're so warm. Does 2x plus 32 equal the whole thing?
No, it equals one angle.
What's the measure of one angle in an equilateral triangle?
60. So 1 plus 60 is 80.
So what is option number 4? 2x plus 32 is equal to who? 60. Folks, solve for x, please. 14. Hey, y'all talking about that problem, right?
Yeah.
2x is equal to 28. Divide by 2 and you get 14. Folks, are you going to think about that? When you're dealing with those equilateral triangles, are you going to know that those angles are 60 degrees each? You going to know that?
Yeah.
You have to know that. Here's another one. What example? 4. How about this one? Folks, what kind of triangle is that? That's an equilateral. The way it's marked, it's equiangular, which means it's also equilateral, which means what? All sides are equal. Why can I not set those two equal 180? Because this is dealing with sides, not angles. The only time we use 180 is when we're dealing with angles. Would I set them equal to each other? Why? Because they're equal. Because they are equal. The equilateral, write this down, triangle theorem says if all angles in a triangle are congruent, then all sides in that triangle are also congruent. And that means that these two sides will be congruent, so we're going to set 5y minus 6 equal to 4y plus 12. And then what are we going to do, folks? Now we're going to do the math. What are we going to do? Minus 4y from both sides. Y minus 6 equals 12. Then what do we do, folks? Add 6. What's y equal to? Rock on. Questions? Does it make sense? Okay? I hope so. Yes, ma'am.
How come, like, we did do the one angle? Like, on the angle, on the one before this, we did 60 instead of 180.
Because look what we were given. What were we given? The information we were given was about angles. Angles equal 180 if we add them all three together. But look at this one. What am I given? I'm given side information
But why did we do the 60 thing for the other one instead of 180?
because we were dealing with angles. This is dealing with angles. Okay? This is angle information. This is side info. Side information. Okay? That's sides. When we're dealing with angles, it's 180. When it's sides, it's not. Then we would deal with perimeter maybe. Okay? Questions? Those are the questions you have to ask. Because if you don't, you're not going to have a clue. Okay? Any questions at all? Here's what you're going to do for me. I want you to, we'll finish this up tomorrow. You'll look at 276, folks. I want you to do 3 through 5. And then 7 through 10. That's it. 7 problems. Get a planner.